Hi, I'm Eli Smith. Today, I'm going to be teaching you about the eggshell experiment. Personally, I would use this in a 7th grade science class, but really, you can use it in almost any junior high or middle school science class. For this experiment, there are 2 simple ingredients you will need. First, you will need vinegar. You also need eggs, or at least a egg, depending on how you do the experiment. It also might be useful to have a bowl or a cup. One way to do the experiment is with a raw egg. Another way to do the experiment is with a hard-boiled egg. If you choose to do a hard-boiled egg, it might be helpful to get a parent or guardian to help you. If you do not know how to hard-boil an egg, watch the following steps as I show you. If you are hard-boiling the egg, it's useful if you have a pot so that you can fill it up with water and boil the water inside and put the egg inside. Be sure to put in plenty of water in case some is evaporated during the boiling process. Once you have your water, you will need an oven, a stovetop, or a hot plate to help boil the water. You'll want to set the pot on the stovetop and set it to a medium heat so it can boil. Water can take a while to boil. Be sure to be patient. Be sure to have a parent or guardian during this. You know the water is beginning to boil when steam is being released and water is being evaporated. Once the water is boiling, you'll want to take a raw egg out of the carton and put it in the boiling water. This may be tricky, and you may want a parent or guardian to help you. Once the water is boiling like so, you may want to take a spoon to help put the egg into the boiling water so it doesn't break. Once you see the egg floating in the boiling water, you know it's hard-boiled. After you pull your hard-boiled egg out of the boiling water, you'll need your glass or cup and your distilled vinegar. You'll then pour your vinegar into the cup. You'll want to make sure that it's about 3/4 of the way full of vinegar. Next, you'll want to put your hard-boiled egg into your vinegar. As you can tell, once you put your egg into the vinegar, gases will be released. You'll then want to cover your bowl or cup and let it sit for 24 hours. In case you're doing both experiments, you may want post-it notes and a pencil so you can label which egg is which. So 24 hours after we first put our hard-boiled egg into the vinegar, you can tell that there are still gas bubbles surrounding the egg and causing it to float. Next, we're going to pull the egg out of the cup. Your hard-boiled egg, the hard outer shell, is actually squishy. So what caused the egg shell to go from a hard outer layer to a very squishy outer layer? If we take our egg and keep it out on the table in another 24 hours, we can come back and check to see how hard or how soft the shell is. Which brings up the question of how does our soft egg go back to being so hard after another 24-hour period of just being outside of the vinegar? Eggs contain calcium carbonate. This is what makes the eggshells hard. Vinegar is an acid, so when the calcium carbonate from the eggshell and the acid combine, a chemical reaction takes place. Carbon dioxide is released as a gas. This is what the little bubbles are. The chemical reaction will keep happening until all of the carbon in the egg is used up. Then, this is what makes the eggshell soft, because all of the carbon in the eggshell is released in the form of those air bubbles. When we leave the same egg sitting out on the table for another day, it'll become hard again. This is because the calcium that's left in the eggshell will steal back the carbon from the carbon dioxide in the air we breathe. If you're using a raw egg right out of the cart, you can begin by pouring the vinegar into the cup. You want to fill it up so it's probably about 3/4 of the way full of vinegar. Once you have the vinegar in your glass, you can put your raw egg into the glass. As you may be able to tell, there are bubbles coming off the egg. Bubbles on the eggshell are actually calcium carbonate from the eggshell. This is becoming a gas and releasing. You'll want to end the experiment by putting some sort of wrapping over the top of the cup and letting it sit for 24 hours. When we do the experiment with the raw egg, you'll want to make sure you also have a glass of water 24 hours after the experiment. So let's check on our raw egg. As you can tell, our raw egg is also floating like our hard-boiled one. As you may not be able to tell, you can actually see the yolk because it's become very translucent. For the next part of the raw egg experiment, we're going to put the raw egg into our glass of water. You'll want to be very delicate during this process because the raw egg can break very easily. As you may or may not be able to tell, the raw egg is actually expanding due to osmosis, causing it to become very large. When we look again at a raw egg, we can tell that it is a lot bigger now, and that in fact, the entire shell is gone, leaving only the yolk. The reason why the raw egg got larger was due to osmosis. Osmosis is when water molecules move through a membrane to change from a higher concentration to a lower concentration. In the case with the egg, there was a higher concentration of molecules inside the egg, so water had to enter to cause it to be equal. Thank you for watching my awesome science experiment. I hope you go home and try it too, but for now, I'm going to make some omelets.